let's get started with who we've got, because we don't have a full crew tonight. What we're going to talk about is Chapter 12, which is quality assurance. And I think one of the important things is to contrast quality assurance with testing. They're two different things, but they sound a little bit alike. They're both making sure that everything works the way it ought to. Tonight, I just want to get through evaluating products, and on Wednesday, we'll talk about processes. Okay? So, again, products is what we're going to do tonight, 12.4. Okay. So, what is quality assurance? Well, it's ensuring that the software products are high quality. Now, obviously, testing for bugs, it helps ensure that, doesn't it? But there's so much more to quality than just making sure there aren't any bugs in it. It is related to the verification and validation we talked about before. QA is a management function. So although QA happens at all levels, the reporting of it has to go back to management. So one of the issues is, and we'll get into this, but the minutes that you all are taking in your practice project can be considered part of quality assurance. And in fact, in the minutes, if you were truly doing quality assurance, you would be confirming or discussing how you compare to standards, industry standards, for instance, in all that you're doing. Okay? Reliability, all this kind of stuff. So it consists of procedures and techniques and tools that really help us to exceed, hopefully, pre-specified standards. Without standards, quality assurance entails ensuring that a product meets or exceeds minimal industrial or commercially acceptable levels of excellence. So sometimes you won't find standards for something you're doing because it may be too new. So you look at what's industry and commercially acceptable. So one of the problems that we run into is the elusive nature of software quality. How do you define it? It's kind of tough to do. So that's why we have the standards. We need a quality plan. So part of the early part of designing and setting up the project to develop it is to have a quality plan. How are we going to stay on top of it? We're going to talk about reliability, flexibility, and efficiency, and other things, which we'll go into in a minute. The underlying assumption of QA is the quality of the software process directly affects the quality of the deliverable products. So although we're going to talk about products first and then process, the processes that we use are going to directly affect the product. So we want a well planned out and managed process. Let's see.
Having all of those helps you to achieve certain certifications.
Absolutely.
Like ISO 9001 or CMMI levels.
Mm-hmm. Or if it's government, maybe NASA or NATO or some other things that are out there. Yeah. External pressures such as early release date might impair quality because we don't have the time to make sure that we are abiding by the standards. So, part of this planning up front is how often and when do we have reviews? Are we going to review weekly during our weekly meetings and talk about not only where we are, but how we are meeting our standards and so forth? It's got to be part of the whole total discussion. And those reports from those meetings need to go back to project management because not always will the software engineer, if he's the manager, he or she, is going to sit in on those meetings. So those meetings must report back. So we're going to talk about standards that are characteristics of all the product components. That's the product standards. The process standards define how the process should be conducted. Like, when do we have reviews? How are they conducted? Okay? And again, that's the second half. We'll talk about that more on Wednesday. So how do we develop standards? Well, software engineering product standards is a difficult process. Here's where you've got the different organizations, IEEE, ANSI, Department of Defense, NATO. All of them have actively given standards for software engineering terminology. So even our documentation, and we're talking about the documentation during the process, we need to use the right terminology. The languages, procedures for defining the software requirements. That's our first step, isn't it? And the QA procedures. We have QA teams. So we may have members of each one of the active groups, programming, testing, maintenance, so forth, may form a quality team. And those people are going to get together periodically on some kind of plan. A problem, it's hard to adhere to standards. What about standards such as program formats, design of the documentation? It's all kind of tedious, and people tend to rebel. Right?
And based on what type of development effort you're doing, such as Agile, you don't do very much of it until the end.
Until the end, and some of the pressures of a due date.
Right.
This is one of those things that'll get slighted in the process.
Unless it's a contractual deliverable.
Yes, and if it's Department of Defense, guaranteed. Yeah. So solution, involve the software engineers in the development of the plan, and which standards we're going to abide by. Modify standards regularly. Now these are in-house standards. And provide software tool support. Sometimes there's software tools out there that help you make sure you're doing it by the standards. So what's a quality review? The review is a mechanism in which a group of people examine part or all of the software system or documentation with aim in finding system problems. So periodically you're going to get together with the group that you've chosen for the targeted purpose of making sure you're online with the quality assurance. And formally record them as part of documentation.
A lot of companies in their peer reviews generally require that a quality person be present in those reviews so that they can point out areas that need to be improved.
And a lot of times the value of a quality person is overlooked because they seem to be they're standing in the way of you wanting to do whatever you want to do, right?
Yeah.
But what they are doing is they are experts on the code, meaning not the programming code, but the codes of specifications. And you need them around. Types of reviews, well, design or program inspections. What about management reviews? Process and product review concerned with costs, plans, and schedules. Things that are outside the code itself. Quality reviews work of individual or team, reviewed by panel. So periodically the team is getting reviewed. That's probably one of the places the team does not like. Right? But it's important. And actually I think part of the software engineer's job should be to point out to the team why it's good for them. It's better to find out early that there's a QA problem in what we're doing than to find out later and have to go back for rework or try to reestablish whatever it is you missed. We're looking for mismatches between the specifications and the design that we did, the code, or the documentation. So software metrics. There's a difference between craft and engineering disciplines. I thought this was kind of interesting. Craftsmen use qualitative methods. A little fuzzy there, okay? But that's why you have standards. Whereas engineering is more quantitative, measurable. Okay, so some things are not as highly measurable, and that has to do with the craft. So a software metric is any measurement which relates to a software system, process, or related documentation. For instance, location, person days to completion, methods per class, etc.
You mean lines of code?
That sounds good. Thank you. Sure. I was kind of questioning that myself.
Well, it should have had an S on the front, which probably would have given you the true meaning of it, because it would have been source lines of code.
Source lines of code, sure. Yeah, you don't want the compile lines of code.
No.
Makes it a lot more productive.
Yeah, it'll make it look better. Yeah, millions. I wonder if that's what it is when people say there's millions of lines of code in Windows. Ones and
No,
zeros?
I could believe they were source.
Yes. Control metrics are used by management to control the software process. So these are not controls of software, it's controls of process. Effort expended, elapsed time, these are things that define the project planning process. And also, they help us see where we are against our original plan. So it should be all there. Predictor metrics. Sometimes there is not a direct way to measure a quality issue, but maybe there's an indirect way. So a predictor metrics is by measuring something else, which will tell us whether or not the quality is there. Does that make sense? It's indirect. Okay. So evaluating products, examining a product, determining if it has desirable attributes, asking whether a document, file, or system has certain properties, completeness, consistency, reliability, and maintainability. We'll see this in a minute in more detail. We're going to look at product quality models, baselines and targets. Baselines are the minimum we must meet. But sometimes our product, we have to add a target that may be above the baseline, or a different thing than the baseline.
Or if you're making multiple deliveries, each delivery would be a baseline.
Mm-hmm.
You know, and then you build, the next delivery would build upon
The previous
baseline.
one, yes. Yes. And software reusability, we talked about this before, but whenever we're, especially in the world of modular programming, you always want to look for, is this module going to be something I could use again later on some other project? So we're going to look at Bohm's model and ISO 9126. So this quality model, you look at the general utility, you look at portability. By the way, for each one of these things, you'll notice they only fall in one of these categories over here. So you start over here. So device independence, well, that has to do with portability. If we, and this is probably one of the things that's very common today, especially in web page designing, is it going to run on a PC, an Apple, a phone, a tablet? Okay, so portability, device independence. Self-containedness, is everything there in the product to do what it needs to do? Accuracy has to do with reliability. Completeness, robustness, or integrity all have to do with whether it's going to be reliable. And then efficiency looks at accountability, device efficiency, and accessibility. I'm sorry, just these two. Accountability and device efficiency have to do with efficiency. Down here, Accessibility. People, you know, a lot of times we see software that will make the accountable or accessible to people with handicaps. Okay. For instance, YouTube's now, it's easy to put text at the bottom. Okay. In fact, I understand it's very good now. So, accessibility, communicativeness,
Sounds good.
are all part of human engineering. Testability also relates to communicativeness, self-descriptiveness, and structuredness. And then conciseness, legibility, and augmentability have to do with understandability and modification, modifiability.
Accessibility is also in efficiency, and I was trying to figure
Yeah,
out.
it is.
And I was trying to figure out how that really applies, but it actually does. I think it would be, how efficient is it that the handicapped person is able to use it?
Exactly. Yeah. Yeah. Because otherwise you'd need another tool
Yeah.
external. It's also in testability.
I mean, do they need 10 steps or 1 step to do it?
Yeah, right. Right. And is it going to be something they can figure out? Okay. So Bohm's model reflects an understanding of quality where the software does what the user wants it to do, requirements, uses computer resources correctly and efficiently, okay, is easy for the user to learn and use, as do with our screens, is well designed, well coded, and easily tested and maintained. And you can see where the standards all direct us to being successful in these areas. ISO 9126 quality model. It's a hierarchical model with 6 major attributes contributing to quality. I'm sorry, here's where the right hand has only one left hand. I mix that up with both. Okay. Each right hand characteristic is related only to exactly one left-handed attribute. So when we look at that model, it looks like this. Here we go. So the ISO 9126 model looks at suitability, accuracy, and interoperability and security. That's all part of function. Maturity, fault tolerance, and recoverability all have to do with reliability. Think of these. Actually, this one looks messy till you read it, and then it begins to make a lot of sense as you're reading down it. Understandability, learnability, and operability. Usability. Time behavior. Okay, is it using good, a minimum number of cycles to do what we're supposed to do, right? Time behavior, resource behavior, efficiency. Analyzability. If we have a problem, can we analyze quickly where the problem is? Modularity helps us with that. Changeability, stability, testability, all comes down to maintainability. And adaptability, installability, conformance, and replaceability all goes into portability.
An additional note on analyzability. Something that also makes it easier to maintain is when the system, or the programmer, engineer, whatever you want to call them, has put in enough diagnostics, error messages. I've been in places where I've seen people, you look through their code and there is no error checking.
Oops.
And it was like, this can't be. And
Wow.
so if there's enough error checking in there, which actually, if it does nothing more than just produce an error message, at least that helps the maintainer identify where the problem is.
Yes. And that brings back a nightmare I ran into with Oracle Forms early on. A product that was supposedly a done product, and I was just going to rep it in my company. So I picked it up. And there were times when you could put a value in a field and you would get a database error. You do not want a customer getting a database error. It should have, and it had the ability to trap errors and give you back whatever you said to it back. This is not a valid product number or whatever. Yeah. And that's how I learned Oracle Forms, because I had to go back in and fix all that. Okay, so here we talk about baselines and targets. So baseline describes the usual or typical result in an organization or category. Okay, so baseline comes from history, comes from the standards. They're useful for managing expectations. That's always important because you want your whole team on the same page. Okay? Those
Also,
are the internal expectations.
Well, also the baselines also provides the customer for customer reviews that you are making progress because you've reached what defines this baseline. You've accomplished all these milestones that defines that baseline.
It defines that baseline, yeah. And especially with quality, because quality is such a nebulous thing. As long as you can say, no, here's the baseline for what we should be doing, and we have this, and this recorded as having met it. Now, a target is a variation to a baseline, and that's because maybe our particular application that we're building, there was no existing baseline criteria for what we're trying to measure. Okay? So we create a new target, and it's a minimal acceptable behavior. Okay, this is Wednesday. What did we do? Oh,
You're right on
gee,
time.
it's right on time. Can't believe it. Okay.
So, those of you who weren't here, we're adjourning over to the lab because he has to leave.